Hi, this is Russ Anderson. Today I'd like to take a look at coordinate systems, which are kind of one of people's common hangups, trying to understand what is up with this whole thing and what are the problems, how can I think about it? Because a lot of what people need to do to understand coordinate systems is be able to visualize what SynthEyes is doing. You don't really have to know the details of how it's doing it, but the idea of what really are we trying to accomplish. So I just did a quick solve of the little sample shot here. Should have all seen by now. So here we have an initial solution. It just was used in an arbitrary position and orientation in space. But, you know, we have a good solution over here. We look in the camera view. As I scrub through this, everything's locked up. Now I can go over here to the 3D panel and I'll select my camera. I'm just going to lock it up there and turn on this whole button. And now I can move this whole solution around in space however I want. And as I'm doing this, you're seeing everything shift around, but the camera view over here is still staying exactly the same. Everything is still locked up. That's because the whole solution is being adjusted to match. So I could do the same thing with rotation as well. And again, the solution is still perfectly good, and there's really nothing to say whether any one of these solutions is better than the next or worse. So the issue really gets to be, when I want to pick a coordinate system, is what's going to be most helpful. You know, if I just take, you know, whatever I've got right now, and I can drop in a little box onto the ground plane, it's going to show up at some weird place in space, and that's not really too helpful. You know, if I wanted, I could futz around with the box and get it in some place where it does something useful. But that really wouldn't be, you know, it would be more trouble than it's worth. I could also use the perspective view, and I could move the grid around in the perspective view and set up the grid on the actual ground plane, even though the points are somewhere up in space somewhere. Again, a bit of trouble, perfectly possible. But the whole point with coordinate systems is to be able to have SynthEyes do the work for you. So let's just get rid of our box here. And so what's the idea? The idea is to be able to take our whole scene and move it around to accomplish some particular setup that we want. Now, in the general example solves this, I usually use a couple of these points here to be the ground plane. So let's say we grab one of these points here, and we'll go over and we'll just make it orange, so we can tell which is which. So it's sitting over here. You can see it in each of the views. Somewhere, there it is. Now, suppose I wanted to make that be at the origin. Well, I could just go and adjust this scene to do that. So let's go and do that. I'll just lock the camera up to make this easier. And let's just start moving things around. I can zoom in here and do this pretty accurately if I want. I have to do it in each of these different views. And really, I'm changing the position of the scene along the X, Y, and Z axes to achieve what I want. So they're the three position axes, and I have to adjust the entire scene along each axis to achieve the position that I want. Now I've gone and done that. And again, I'll point out, you know, this is a manual way to do things. You could do it this way if you want, but I'm trying to illustrate what SynthEyes ultimately is going to wind up doing. So having done this, you know, then I have to go and adjust the orientation of the whole thing as well. So I've got kind of this slanted ground plane here, if you like. So I could go and rotate the whole thing around. Even, let's see. Even do it in the right spot if I work at it, but just the way I did it, I need to readjust things a bit. But now I've gone and done some more of the alignment here. And now the one direction, I've adjusted it from the left view, I've adjusted it from the front view, I haven't adjusted it from the top view. So that each of the 3 rotation axes has to be adjusted. Now it might be that this is good enough, that you don't really care. If I drop in a box now, I'll get some kind of slanty thing there because I haven't adjusted things from the top. So I could go now and maybe use that as a way, not what I wanted. I could go and spin things around this way and use this as a way to adjust orientation if I want it. So, now I've set up a coordinate system for that box. And again, I could go and adjust things back to the origin if I wanted there, that point really to be at the origin. Or I can move the box around, do whatever I want it. Point is, that's a lot of futzing around. The whole point of the coordinate system in SynthEyes is to be able to do this process automatically and therefore quicker and more accurately. So I'm going to switch over now to the constrained points view. The constrained points view is the first thing that I look at when somebody sends me a shot and says, oh, I'm having trouble with the coordinate system. The first thing I do, take a look at the constrained points view and see what they've got in there. So let's use the constrained points view to watch what happens as we set up a coordinate system. So we're going to use the *3 button to set up a couple of points. So the first one is the origin point that we click on. And as I do that, you see up here a new line appears that has the tracker number listed. It's being constrained along the X, Y, and Z coordinates. And you can see over here in the actual coordinate system panel that's listed as the origin. And here are the coordinates it's locked to, X equals 0, Y equals 0, and Z equals 0. And you'll see where it is right now. And it's, it's close to 0 because I had adjusted it manually. But there is, in fact, an error. And here you see the actual error number, how far away it is in 3D from the coordinates that I want. So the constrained points view is giving us some idea of what's happened. So now let's go and click on the second point. And this is one that by default is along the x-axis. If I had clicked again over there, I would have had the FB displayed, and that would have been front to back and would have put it along the y-axis. But here we've just got along the x-axis. So here's my point. Number 86 is locked to x equals 20, y equals 0, z equals 0. Here's the current solved position. And you'll see there's really quite a large error right now because that wasn't something I've set up at all. So I've got an idea of what I've got in the scene already. Now I'll click on that third point. And you'll see here's our third point. And it's only being locked in one axis. Really only the 0, z equals 0, is being locked. You see that the axis is locked over here. You see only the value being selected there. And you see some error values showing only the z error is really applicable. And that's all you need to specify a coordinate system. You've got the origin, you've got this point along the x-axis, and that's kind of setting up some direction axes. And it's also setting up the scale, and we'll look at that in a minute. And this third point just kind of defines the twist, controls the twist around the x-axis. So now when I go and apply this coordinate system, just goes and updates the solve, and you see that now all those values match up, and the errors are very low. And that means we've been able to adjust the scene to achieve the coordinates that you want. And if you apply a coordinate system and you see that these error values are still substantial, that means that your coordinate system setup can't be satisfied simultaneously. So you've done something that's equivalent to saying, well, make x be 3, and, oh, by the way, make x be 5. So you're going to tend to get something like x equals 4, but you're going to get errors in each of those two constraints that you'll see over in this last column. And that's your clue that, oh, you know, what I'm trying to do really isn't self-consistent. But that's a basic setup, and you know, this is what it looks like in a z-up coordinate system for a simple ground plane. And you get a similar sort of thing, you know, using one of the other coordinate systems, and you can easily switch and see what happens. So I just switched here, and now you see SynthEyes went and is showing you the constraint differently. Now with the y-up coordinate system, we're setting y to be 0, and everything's still the same, just kind of the labels and the axes have changed around a bit. So this default kind of setup gives you not only the coordinate system positioning and orientation, but it also sets the size. And the size is actually the one thing I didn't show in that earlier thing. Let's just run a couple different flavors of this for a minute. First, let's do the star 3 again. So we'll get rid of these existing locks. And this time I'm going to just take that first point there, and now I've selected the front back option, and I'm going to select that second point. And now you see that it's putting that point at y equals 20. So we're going to have a different scale to the entire system, as well as having it oriented a bit differently. So you see things shift around now down here. But you still wind up with the same situation where the errors wind up 0, and there's a point at some particular point along the axes. Now, you may, in fact, have a measurement between some other trackers that you want to use as a sizing constraint instead. So, you know, I might have two trackers over here and know what the distance is between them, say, that I've measured on the set, and want to use that as the scale. So let's take a look and see what it would take to do that from this setup now, and we'll watch what happens as we do that. So let's go and take this one point, and right now it's being locked to that position, the y equals 20 along that y-axis. So instead of being locked to that point in each of those coordinates, we'll just say that we want it to be along the y-axis. So now the x is 0, z is 0. But we don't really care what's happened along y. We don't know what that y value is, because that's going to be determined as a result of the scaling that we applied differently. So this is what you see in your constraint points view now, and it doesn't define any scale for the scene yet. So let's do that. Let's take those 2 points, and we can either use this drop down over here, or we'll just alt-click to set up a link between those 2 points. It's probably hard to see here, but there's a nice little gray line between those 2 points. So now you see another line has appeared here that shows that link between the 2 trackers. And I'll point out, you can get sort of all the different combinations of coordinate system setups. Here I've locked, number 82 to 34, and I don't need to add a lock from 34 to 82. So you can always, when you want to set up a distance constraint like that, which is what we're doing, it's okay, even if it involves one of these other coordinates, one of these other points that you're already using as part of the alignment. You just use that other point, that 4th point, as the one that holds the link back to the one that you want. So if I now take that little link that I set up, and I can set some distance. So now I've said the distance between number 82 and number 34, I want that distance to be 5 units. And you'll see, I've got some error at this point in time. So I can just go and a little of that. Resolve the scene here. And now I've got that distance that I wanted. And you see the error is again low, and this overall size of the scene has been updated. And so this gives you an idea of here I'm starting to build up some more complicated set of constraints. And I'll just go and set up something else here instead. So let's suppose that we wanted to keep on using this first one as the origin, but instead of using this setup that we've got here for this point to be along the x-axis or the y-axis, let's take that away. And now let's suppose that we want to use two other points. So we'll take this number 86 out here. Actually, that's the one that I've already used a little bit. So I could use that, but for illustration, I want to use some different ones. So let's take this point down here, and we'll take another point over here, and we're going to set up a link between them. But instead of using this one as a distance, what I'm going to do is say that those are parallel to the y-axis. So now instead of using the points over here to be the y-axis, I'm going to use this line between these 2 points to be the y-axis. And I still need to have a planar constraint here. In this case, we've got this number 86 that says that it still has to have z equals 0. Still need to have that because this line here, the entire scene could spin around that particular line, and it would still solve that constraint. So that's why I need still to have a third point. But this gives me another kind of different set of coordinates, or different coordinate system setup that I can use. And again, you see that I can solve it and get a 0 set of errors. It's a consistent set of constraints. Now, if I wanted to go and take some other point here, and let's just say that we put that one on that ground plane as well. Okay, now I've got actually 2 different points on the ground plane. So if I go and I redo the solution, now you see that there's an error in both of those constraints. They can't both be satisfied at the same time. So you see it kind of ripples its way into a bunch of different things as it tries to keep everything happy at the same time. So that's what you get when you have a conflicting set of constraints, and that's a clue that you need to look at it. So let's just go and take this particular constraint back away. And let's look a little more carefully at this constraint on trackers 82 and 34. Now, right now we've got it set up as a distance between those two to be 5 units. Okay, and it's important to be able to read this display here carefully. Now, this first column over here is showing exactly which coordinates of the tracker are locked. So here in the first one, I've got the x and z values are locked. Since in the second part here, there's only the tracker 97, x and z of tracker 61 are locked to x and z of tracker 97. Here in the second line, the x, y, and z coordinates of 64 are all locked to the specified coordinates that are coming from these spinners over here. On this third line right now, we just have a distance constraint, So the distance between these 2 points is set to be 5 units. But I can get that a bit more complicated if I want. Say, well, I want those 2 points to be parallel to the x-axis and still be that certain distance apart. So here I see y, z, and d, saying that the y and z coordinates of tracker 82 and 34 have to be the same. And oh, by the way, they still have to be 5 units apart. So that means that at the 5 units is going to be a difference in the x values. So that entire scene could slide along that axis, if you like, and it would still have the same distance between those 2 trackers. Just on the basis of this individual constraint, the entire scene could rotate around that line also. So if I was going to use just this constraint, I would still need another one like the one down here to say exactly how that other rotation axis is going to get nailed down. So there are a lot of different possibilities to this. It's important to be able to read this panel and understand a bit what it means. And there are a lot of different combinations of putting things together, since you can have 82 locked to 34, but 34 could in turn be locked to some particular coordinate values as well. But it's important to recognize that in all those cases, what's really going on is SynthEyes is taking this list of constraints that you've given it and just moving around the entire scene to try and best satisfy the constraints that you've given it. And as it's doing that, your lock over here between the trackers and the 2D images and the 3D world, is staying unchanged. So it's just moving the whole thing around, scaling it up and down, trying to get it in a place that's really going to help you do the rest of your job as easily as possible. Now, things do get more complicated as far as that view of the world is concerned if you turn on this constraint checkbox, because that does make these constraints start to affect the solve itself as the scene is being worked on, and can be used to straighten the scene out and do some other things. I think we'll save that as a topic for another day. Thanks a lot. I hope this helps you understand what the coordinate system situation is all about. Keep in mind, always got to be visualizing what it is that you're telling SynthEyes, telling it how you want it to position that entire scene within your overall top, left, right, etc. views. And really that's all it's about. Thanks.